Hi, everyone. Thanks for coming to my talk. Before I start, let me introduce myself. My name is Vanessa Henderson, as I was just introduced. I am a graduate from the AUT University in New Zealand. I am a security researcher at a company called SourceClear, and I'm a level 20 Pokemon trainer. But Team Instinct. No? Okay, just me. So what are we going to talk about today? Well, as the name of the talk suggests, we're going to be talking about copy-paste vulnerabilities. First, we're going to look at how you might get them in your project and how you can identify those in other projects, a case study that I did on the top 8,000 GitHub projects, and recommendations and further study areas which could potentially come up in the future. And then we'll have some time for questions. So what are copy-paste vulnerabilities? They are exactly what you think they are. They are where people have taken a vulnerable dependency or a slice of code that has a vulnerability in it and has taken it and copied it into their project and used it for themselves. Now, that seems pretty straightforward, but there are actually 3 different ways that this might come into your own project. The first being where you take a full dependency. So say I have my project, and in my project, my index calls handlebars.js, which is a front-end library for templating. So you can take values from the back and send them to the front through templates. And I don't want to call a package manager because I don't want to have to connect to the internet for the CDN or to install my packages. So I take this class, and I just take it directly into my project. Now, I didn't realize at the time that this was a vulnerable piece of code, and now my entire project is vulnerable. The second way is through code snippets. So I know we are all very guilty of this. When you can't figure something out, you just don't know how to do this one piece, and so you start Googling it. You find an answer on Stack Overflow, or you find an answer on GitHub, where someone else has implemented the same thing you want to do. I mean, I'm sure you've all heard the saying, why do it if someone else has already done it? So here, I'm trying to generate a random integer to use as an ID, and I didn't know how to generate a random number. And so I take math.random to do this. But at the time, I didn't know that math.random isn't actually true random. It will repeat eventually, and therefore I could get collisions on my ID numbers. And therefore, my id.java is now vulnerable. But this is not the only type of code snippet that might be copied. Another common one is regular expressions. So regular expressions can be used to match slices of text against a format that you want. So this one here is designed to have a 24-character string, which has characters 0 through 9 or A through F. But if this is in Ruby, unfortunately, the top hat and the $sign don't actually indicate the end of the string. It only indicates a new line, which means that if you do put a string in with a new line halfway through, well, you can be vulnerable to XSS. The one you're actually looking for is this one here. Now, this specific vulnerability was actually found by Igor Homikov in 2012, I believe, and it was actually found in GitHub. I know most of you probably have used GitHub at least once in your life, but this was actually, if you had a URL in your profile page, you were actually able to access the website and anyone who entered your page. The last way is through porting between languages. This one is a lot more complicated to figure out. So here I have the class Mustache, and it is another templating language very similar to handlebars. It has a set of characters which it uses to escape text so that it obviously doesn't create JavaScript of its own, so you can't XSS someone. Now, when Mustache just first arrived, someone took this and turned it into JMustache. And they implemented the same escaping characters into Java. However, after they had ported this to Java, they realized that it was missing 2 different escape characters. The first one that JMustache is actually missing is the backtick. If you don't know, the backtick is actually a coding character. So if you're using IE, it can actually be taken as the same as quotes, and therefore it can be used to cross-site script. The second one that they are actually both missing is the equals character. I did a POC a few months ago on this specific vulnerability, where I was able to set up a small web application and leverage the fact that they didn't escape the equals character to perform XSS. And therefore, JMustache is vulnerable. Now, what are the challenges of identifying these vulnerabilities? Well, the first one is minification. Sorry. Minification or obfuscation is something that a lot of JavaScript developers do. Minifiers and obfuscators will take any white space from a project, as well as any comments and any long variable names, and rename them to make it all a single line file. Now, this file is often concatenated into a single file. Developers do this so that not only do they have less files in their project, but the files are also smaller and easier to deal with. It also means that the developers only have to import one class when they are developing. Now, the last one is the code structure between various languages. As we saw with our Java and JavaScript example, here in Mustache, it is written in a JSON blob. However, over in Escapers, it's written in a 2D string array. Now, in the time frame that I had for my study, I wasn't actually able to find a way of identifying these different codes. Sorry. I wasn't actually able to find a way of identifying between the different code structures for the languages in an efficient way that would allow me to identify these at scale. But the way I did identify it for the study consisted of two different ways. The first one was string matching. So I compiled a list of all of the minified versions, the full versions, and the .map versions of the vulnerable JavaScript files I wanted to find. And I iterated through each file in the GitHub project I was scanning and looked to see if it contained the string. I by no means am promoting this way of matching. It is incredibly slow, but it worked for the purpose that I needed. The second way that I identified files was through hash matching. So hash matching allows you to take a single file and put it into a set of characters, which will be unique to that set of characters. If even a single space or a single character is changed, the hash won't match. So whereas the hash matching didn't allow me to identify the concatenated files, it very accurately was able to identify full files that had been copied. Whereas the string matching helped identify concatenated files, as well as people who had just taken a subset of the file and taken it to their code. And so here you can see I'm cloning each repository that I'm scanning, and then I'm walking through the tree of files and hashing each one and searching each one for our vulnerable strings. Now, what exactly did my case study entail? I scanned for 16 different vulnerabilities. 15 of them were JavaScript files and JavaScript vulnerabilities. 5 of those were cross-site scripting. And then I searched for 10 different regular expression denial of service vulnerabilities. So the regular expression denial of service vulnerabilities were ones where there was a single regular expression, such as the one we saw earlier, that is responsible for bringing down an application. The last vulnerability that I searched for was in the popular package libxml from C, and it was an out-of-memory denial of service vulnerability. I scanned the top 8,000 projects on GitHub from the following languages, as seen on the screen behind me here. These were the top forked projects because I found that if a developer is more likely to fork a project if they're actually interested in using it because they want to have a stable copy that they know works with their application. So what were the results of our case study? We found that out of the 8,000 projects that we scanned, there was over 600 which contained a vulnerable file. Now, if you think about on GitHub, there is 2.2 million projects that is growing by the day. And if you take this ratio and apply it to all of GitHub, there is 165,000 different projects which could contain a vulnerable file. Now, that's insane. And I only scanned a very small subset of GitHub. Can you imagine if someone used the BigQuery GitHub that has just been released and tried to find copy-paste vulnerabilities? It could be insane. But we didn't want to just stop at vulnerable files. We went one step further. We went and found vulnerable methods. What is a vulnerable method, you say? Well, the concept comes from if you're not using the exploited code, then you're not vulnerable. The same way if you're a vegetarian. If you're eating the pizza on the screen behind me, if you're eating the cheese half, then you're not eating meat. Whereas if you're eating the pepperoni, well, then you're eating meat. So if you're using the vulnerable method, which is the meat, then you're vulnerable. Obviously, vulnerable methods are not 100% accurate, but it definitely gives you a better sense of whether you're vulnerable or not. There are ways which you can circumvent the vulnerable methods analysis, such as if you've implemented in your code a way of circumventing it. So if you have your own escaper as well as using the handlebars escaper, then you might not actually be vulnerable. So how do you go about identifying a vulnerable method? The first thing we do is identify the root cause of the vulnerability, the vulnerable method. So this is the method which uses the regular expression, or the method which has math.random in it. And then from there, you find all of the call chains which could possibly reach that vulnerable method. For example, in the one on the screen here, you've got A, B, and D, which all can lead back to the vulnerable method. But if you're just using method C, then you're in the clear. I mean, it doesn't mean that you can't be vulnerable in the future because you still have the vulnerable file, but it's not as critical because you might not be able to be exploited right at this moment. And then once you've identified the different call chains that might come back to the vulnerable method, then you can look at your project and see whether they're calling those methods. And so what happened after that? We had 42 different disclosures that I will show you some in a minute. But first, let's actually see whether this is possible. So one of the projects that we found was vulnerable was Adam P's Markdown here. That is, just as the name suggests, it's a Markdown renderer. And it was vulnerable to one of the regular expression denial of service vulnerabilities that we were looking for. And so here I've got a demo. This is their website where they actually have a live version of the Markdown renderer working at the bottom of the page. So before I actually start playing around with it, I'm just going to click on some of the links down the bottom so that you can see that the website is currently functioning. Great, it opens a Markdown sheet. Perfect. So I'm just going to remove this text here because I'm not caring about that, and switch over to my other screen where I have a vulnerable string. It's a lovely flames, flames ASCII art. So I'm going to copy that, and I'm going to put it into our text editor. As you can see, nothing appears on the screen, so it's clearly not rendering it as it's supposed to. And even worse, now when I try and click the links, nothing happens. So the website has crashed, and I almost crashed my computer doing this demo because it kept trying to render it. So I'll just let that play through again, just in case you missed it the first time. I really do like this ASCII art. It's flames. It's because it's blowing things up, right? And there we go. It's broken. So behind me here are some of the ones that we disclosed to. There are some very popular packages that you can probably see in there. UE is one of the main ones that we found that was vulnerable. They actually did respond to our vulnerability disclosure, saying that despite the thousands of users that are using their product still, they weren't going to fix it because it was deprecated. And out of the 42 disclosures that we did, only 5 actually went on to fix the vulnerability. Sorry. Whereas a whopping 31 different projects did not even respond. That's not a good ratio, but that's another talk entirely. So how can you avoid these vulnerabilities? Well, the first one, don't hard copy packages. I know it is so tempting, and I know you want to, but just don't. Wow, I'm like crying, guys. I'm very passionate. The second one is, well, use a package manager. I know it might not seem like a great idea at the time, but package managers allow developers to put deprecated warnings. So for example, one of the regular expressions we were looking for was in this mini-match package. Now, mini-match actually went ahead and said, okay, I'm going to deprecate this package. So anytime you try and install this package from that point onwards, it will tell you, hey, look, in your blog that you're trying to install, there is a deprecated package because it has a regular expression denial of service issue. And that's great. And also, if you're using a package manager, it will allow you to use tools such as sourceclear.com, subtle plug, which will scan your package managers and tell you whether you're using vulnerable packages. And lastly, how could this study be taken and made better? Well, cross-language identification. I personally didn't have the time to correctly identify between different languages, all of the different types that you might take them to. I mean, the one that we looked at in Java took JSON and put it into a 2D array. But who said it had to be a 2D array? It could be a linked list. It could be a number of other things, a map. And I didn't have the time to identify all of the ways that they could be converted. The second one is a transitive copy-paste vulnerability search. So all of these ones I identified, I only stopped at that point. I didn't go and find the packages which use those packages that I identified as vulnerable. This could be an exponential search, which could actually return so many more things than any of us could imagine at this point. And lastly, does anyone have any questions? Or if you have any questions for later, I'll be around the conference, or you can contact me on Twitter. I am @thefruitykiwi.